Purpose of graphs in statistics is to convey the data to the viewers in pictorial form. It is easier for most people to comprehend the meaning of data presented graphically than presented numerically in tables of frequency distributions. This is especially true if the users have little or no statistical knowledge. Statistical graphs can be used to describe the data or to analyze it. Graphs are also useful in getting the audience attention in publication or speaking presentation. They can be used to discuss an issue, reinforce a critical point, or summarize the data set. They can also be used to discover trend, pattern, in a situation over a period of time. The three most commonly used graphs in research are histogram, frequency polygon, cumulative frequency graph, or we call it ogive. The last one, I think, is originated from an Arab word, an Arabic word. I think it's a jib or something like that. Let's start with the histogram. It is a graph that displays the data by using vertical bars of various heights to present the frequencies of classes. For instance, let's open our Geogebra here. We have some data. We want to look at the histogram. So we click on histogram and voila, this is our histogram. We'll see here that we have 79 entries with a mean of 10.8987. If it's population, the standard deviation will be 7.915. The sample standard deviation is 79656. The minimum we have it's 1. Quarter 1 is 5. The median is 10. Quarter 3 is 14. The maximum is 30. And this is 30 years. That's the maximum we put as a years of service in a company. It's 30 years. And the minimum has been shown to be 1 year for people to be working in this company. This is our histogram that has about 6 classes in it. 1, 2, 3, 4, 5, 6. We can change the classes by clicking here, so you can have more classes or less classes depending how you want to present your classes. Usually between 5 and 15 are very useful, and it's more clear for people not to get lost in the data. So this is what we see from histogram. The histogram is usually based on frequency table. That's we did not show you here how to organize it. That's we do on the paper and on the board. But here everything is going for display. The second graph that is more useful is what we call the frequency polygon, which is a graph that displays the data by using lines that connect points for the frequencies at the midpoint of the classes. The frequencies are represented by the height of the points. So it looks like a line graph. So if I go here, take off the histogram and put the frequency polygon and close this, and voila. So now we have our frequency polygon. You can see it is a line graph versus the histogram was a bar graph. The ogive is based on cumulative frequency, which means it's going to be always increasing graph. It's a line graph that is always increasing. So we use cumulative frequency, and we can see the ogive very clear as shown. It's a graph that starts from the first frequency and it keeps adding the next frequency of the next class until the end, and it looks like an increasing graph. These are the three types of graphs that is based of the frequency table. We have other graphs that we will be talking about on next time. So the other ones, get back to the histogram here. The one that can use the minimum, the maximum, quarter 1, quarter 3, and the medium, which is we call a box plot. It's right here, and you can see the first vertical line, meaning that's the minimum. This is here quarter 1, medium or quarter 2, and quarter 3, and here the maximum. So we'll be talking about this in depth next time. And the other graph, which is very important graph, the stem and leaf plot, stem and leaf graphs. And you can see with stem and leaves how many datas in the 0 first and 1 and 2 so far. So we can talk about this as well and in the other lesson. Okay, let's practice a little bit and give you some work to do. Bye for now.